Okay, so we're going to take a look at how to find x-intercepts from the equation. So the first thing that you want to do is actually double check that there are x-intercepts. And one way to do that is just to make a quick sketch of what you know so far. So from our last question, we had figured out that our vertex was 1, -9, that it was opening up, and that we also had a y-intercept at -6. So one thing you can do with this is just make a quick sketch on the side for yourself. You know that your vertex was at 1, -9, so you know it's down here somewhere. And you also know that it opens up and it passes at -6. So just a quick sketch for yourself. From this sketch, you can tell that there are going to be x-intercepts. Okay, the reason you want to take a quick sketch is because if you were maybe in a situation like this, where your vertex was above the line and we opened up here, then you wouldn't have any x-intercepts, and then you just do a whole bunch of work for no reason. So you want to make sure you check that there are x-intercepts, and in this case there are. So now what we're going to do is a similar strategy to what we used to find the y-intercept. All we know about the x-intercept is that it's along this line, which means we know that the y value is going to be 0. So we're going to rewrite our equation here. But this time, instead of writing y, we're going to write 0. We're going to do a bunch of moving around of numbers and end up with x equals something, and that will show us where our x-intercepts are. So I'm going to write out 0 equals 3 times x minus 1 squared minus 9. Okay? The trick to this is realizing there's a whole bunch of stuff going on in here, and x, what we want, is in the middle. So you want to start on the outside and work your way in. So the easiest thing to get rid of here is the -9. So we're going to do the opposite and go +9, making sure to do that to both sides. Then if we clean that up, that says 9 equals 3 times x minus 1 squared. So the next easiest thing to take off is going to be this 3. Okay, so we're going to divide by 3. Divide by 3. 9 divided by 3 is 3, and that cancels itself out. So we end up with 3 equals x minus 1 squared. Okay, so now to get rid of the squared, you want to do the opposite. And the opposite of squaring something is square rooting it. So I'm going to square root this side to get rid of the square, and then I'm going to make sure to square root the other side. Now what we need to remember is when we take the square root of something, there's a positive version and a negative version. For example, the square root of 4 is 2, because 2 times 2 equals 4, but the square root of 4 can also be -2, because -2 times -2 also equals 4. So there's the positive version of this square root 3, and there's also the negative version. It's okay that we don't necessarily know exactly what the square root of 3 is, just that we understand that there's going to be the positive square root 3 and the negative square root 3. So this whole thing is going to equal x minus 1. Okay, so if I now get rid of the -1, +1, +1, I'm going to end up with, and I'm just going to switch the order here, I'm going to put the x's over here and the numbers over here, x equals the square root of 3, could be the positive version, could be the negative version, plus 1. So there are actually 2 answers here, and I'm fine if you just leave it like this, showing that there's the positive square root 3 and the negative square root 3, or you can separate it into 2, and to separate it into 2 you'd say x equals the positive square root 3 plus 1, and also x equals negative square root 3 plus 1. Okay? So that's how you get the that's how you get the x-intercepts.